Hi, fellow scientists. My name is Izzy, and I'm a student here at Wake. And welcome back for another round of Science Hour. All right, so today we're going to talk about thin layer chromatography, more broadly known as chromatography. Now, have you ever wondered how molecules are separated? No? That's okay, not many people do. But let's take aspirin, for example, which is a headache medicine, right? A pain reliever. We take aspirin. When aspirin is made, there are so many byproducts that are made with it, and we can't just give someone aspirin with all of these byproducts in it. So a commonly used technique that we use here in the lab as scientists to separate molecules is chromatography. So we take advantage of the molecule's properties to separate them. Today, we're going to use ultra-clean washable markers, such as these. We are going to use a pencil and a clean sheet of paper. And then we're going to use our handy-dandy And then we're going to use our handy-dandy mason jar. That's what we're doing. And straw. Tape. Doesn't have to be green tape. You need tape and scissors. Now, the first thing that we're going to do is we're going to cut out a piece of paper about this long and this thick. So I would say fold your paper in half, and then fold it into another half, hot dog style, and then just go ahead and cut about a finger's worth from the end. And we're going to say, this is what we should get. Now that we have our strip of paper cut out, we're just going to draw a simple line and just lightly trace over it once, and your marker line should look like this. Now, we're going to use a straw, and we're going to wrap this top of the paper. We're going to use a little bit of tape to make sure it doesn't unroll on us. This is what we should have now. You want to fill that up to about a finger's worth of water. Now here's the important part. You want to make sure that whenever you dip it in, that only the bottom touches the water, but not where the marker line was drawn. So now, dip the paper, so like this. Let's stand back, wait about 10 to 15 minutes, and see what happens to our marker line.
A few moments later.
So let's see what we get. So, if you look closely here, this is what we get after a few minutes. But, just to prove that this line once was down here, we can see our pencil outline from before. So what happened was that where we drew our pencil line and then where we marked with our black marker was the same line, but our black marker traveled up the piece of paper using water. So the water made the marker go up. Because these are washable markers, the dyes dissolved in the water and made it travel with the water. Now let's talk about the science behind all of this. Now there are three components to chromatography. The first one we want to look at is the compound of interest, or in this case our markers or our colors. The second component is we have to have a stationary phase, and then the third component is the mobile phase. So now think for a few seconds. If our markers are our compound of interest, what is the stationary and what is the mobile phase? So the mobile phase is going to be the solvent that we use. In this case, we're using water from a mason jar. And the stationary phase is our paper. So if you think about it, when we mark our paper with a marker and then we let water run up through capillary action and it pulls all of the colors with it, we can see that the paper doesn't go anywhere, but the water is what travels up. So that's why the paper would be our stationary phase. The water would therefore be our mobile phase. And then of course our compound of interest is the marker that we see travel from the bottom all the way to the top. So, like I said, we saw the line, we see the marker colors separate, and we see, of course, our stationary phase hasn't changed. Nothing happened to the stationary phase. What happened instead was that the mobile phase traveled from the bottom all the way up using capillary action, and we see, of course, a separation of colors into green, red, and purple from black. Now here's where the fun part comes in. You at home can try from these different colors, the same thing, just draw a line with any one of these 8 colors and see what colors they separate into. My thoughts, my hypothesis, is that darker colors are made up of more colors, so they might separate into more colors, but we're not sure. Give it a try at home and see what happens, but just try the same thing with all 8 markers and see what you get. But another thing that you could try is, instead of just using water, this is 100% water, I would try 100% rubbing alcohol. Or I would even try, actually, a mixture of rubbing alcohol and water. So like a 50-50, 1-to-1 of alcohol, rubbing alcohol, and water. And see if the composition of the mobile face affects how the colors separate. So try that, and a combination of solvents plus all 8 markers, you might get better separation than we did with just 1 marker and 1 solvent. So give that a try. All right, fellow scientists, thanks for joining us again here on Science Hour, and we'll see you next time.